It's an honor for me to be one of the presenters of the DigiCrop 2022 online edition. I'm Mattia Balestra, an Italian PhD student at the beginning of his second year. I have a background on the agronomy and the forestry sector, and I'm part of the SFARM Research Center. What is the SFARM? The SFARM is a smart farming research and service center, and this is a scientific structure of Università Politecnica delle Marche in Italy, which allows synergies and collaboration among different expertise. It promotes knowledge integration by means of multidisciplinary activities, the enhancement of laboratory equipment to boost research activities, academic and professional training in precision and smart farming, and the involvement of companies and institutions working in the local community. There are three departments that are part of this farm: the Department of Agricultural Food and Environmental Science, the Department of Information Engineering, and the Department of Construction, Civil Engineering and Architecture. Several professors and researchers of these departments cooperate with this farm. Moreover, there is an UniVPM extension and research center in agriculture. The SFARM Research Center leads several research activities in the context of advanced digital technologies for sustainable agricultural production. Artificial intelligence for small-scale farming is one of them. In this project, a stabilized gimbal was used to acquire data in two fully irrigated crops, beans and lettuce, using two multispectral cameras operating in the near and in the vis ranges, with an automatic calculation of exposure time on a spectrum reflectant target for both cameras. A team of agronomists labeled the images in order to build a dataset, catching weeds by their shape and the spectral info. By this work, artificial intelligence can support machines removing weeds by mechanical action. Same technology used for weeds was used to estimate the number of olive fruits and their ripening stage. A detection network was used to isolate the high olives, and a bounding box was obtained for each olive. The background was isolated by means of different approaches, such as the RCNN and the ellipse detector, and the ripening estimation was carried out using CNN and classical machine learning approaches of multispectral histograms. There are still some challenging issues, such as the unbalancing of the datasets and the shadows over the olives. In this project, we used monitoring system to enhance pledmont farming. The data were collected in a chestnut and an hazelnut groves by means of weather station and different ground sensor mounted at different ground depth, and, moreover, by imagery collected using drones and satellites. All this data were analyzed as time series to evaluate the grove's healthy status. In this project, named BioCereals 4.0, different satellites images were used to analyze wet crop production. The PlanetScope satellite has a resolution of 3 meters, while the Sentinel-2 has a resolution of 10 meters. The second one is a free-of-charge satellite. Using the functional principal component analysis on vegetational index values, such as the normalized difference vegetation index, the values were analyzed by their principal component, and the time series of each pixel was reconstructed and isolated using these components. By the FPGA key means, 3 clusters have been individualized. At the end, a hill map was realized for the same field in the same time span to evaluate the difference in terms of confidence of the predictive model builds. Finally, in this project, a mobile laser scanner named Carta Stencil 2 was used. The light detection and ranking unit was used to measure olive tree crown volumes under different pruning techniques. With this laser scanner, we collected a point cloud of an olive grove pre- and post-pruning, and we extract different tree metric data, such as the height and the diameter at breast height of each tree. The first thanks to the normalization of the above ground points, and the second through the vertex triangulation algorithms. Then, by manual filtering in cloud compare software, it is possible to remove the ground, and through the quantitative structure model algorithm, a 3D model is reconstructed in the 3D forest software. Thanks to these models, we were able to extract the wood volume of each tree. Then, by the reconstruction of the olive tree crown by different algorithms, such as the Delaunay, the alpha shape, and the voxel one, we calculated the crown volume, pre and post pruning, and we compared the results with the ground truth collected in the field in order to set the best algorithms for the tree volume calculation. That's our most interesting works of the last years. Here you can find our contact details for any question and or collaboration with our SFARM team. Thank you for your attention. Goodbye to everyone.